ladies and gentlemen.
Let's solve rational equations. So when we solve a rational equation, we have to be careful because we have the possibility of dividing by 0, and we can't do that in math. So if we get an answer, we have to check that we don't divide by 0. In addition, we're going to try to clean up our equations by multiplying both sides of our equation by the least common denominator so that when we solve, we kind of get rid of these pesky fractions. So if I look at the fractions in question 1 here, I see that I have a denominator of 3, a denominator of x minus 1. Neither of those share any factors. So the least common denominator here would be multiplying them together, which would be 3 times x minus 1. So we are going to distribute that to all 3 terms. When I multiply this fraction by the least common denominator, any common factors would cancel in the numerator and denominator, which would make our life easier to cancel them out now. So what I can do is since I'm dividing by 3 and multiplying by 3, I can just have this 2 times the x minus 1. Here, the x minus 1 would cancel, leaving me just with this positive 4 times 3. And then on the right-hand side, nothing would cancel, just leaving me 1 times 3, which is just 3 times this x minus 1. From here, we can multiply and simplify this out a little bit. 2 times x is 2x. 2 times negative 1 is negative 2. 4 times 3 is a positive 12. And then here on this side, we have 3 times x, which is 3x, and 3 times negative 1, which is negative 3. So let's move all of our x's to one side, all our numbers to the other. So I can do that by subtracting 2x on both sides, give me just a singular x on the right, which means I want to move all of my numbers to the left. So I can add 3. Negative 2 plus 3 is positive 1, plus 12 is a 13. So x is equal to 13, but we're not done. We're going to check this into our original equation where we have this x minus 1. And if I plug in my 13 there, I get 4 over 13 minus 1. So I get 4 over 12, and we are allowed to divide 4 by 12, so 13 is our answer here. The next one is a little bit different because all of our fractions have a variable. In addition to that, we actually do have some common factors in our fractions with variables. And I can tell that because this quadratic here is factorable. And I can factor this to be t plus 2 times t minus 1. And if you notice, that means I have a common factor of t minus 1, a common factor of t plus 2. So my least common denominator here is going to be this t plus 2 times t minus 1. So let's go ahead and multiply all parts by this t plus 2 times this t minus 1. So when I do this, like before, I'm going to cancel out the common factors in the numerator and denominator before I write it down to make my life a little easier. So this t minus 1 and this t minus 1 would cancel, leaving me just 1 times t plus 2 plus this 1 times, and this t plus 2 and this t plus 2 would cancel, leaving me just that t minus 1. And then here, both of them would cancel. The t plus 2 would cancel, and the t minus 1 would cancel, leaving me just with that 3. Here, I don't really need to have this multiply by 1. It doesn't change the value. You could distribute it out, and you'd end up with the exact same thing. For me, I'm just going to save myself that step of writing it down. Here, we can combine our like terms. So we have 2t plus 1 is equal to 3. And then we can subtract by 1, so getting us 2t is equal to 2. Divide by 2, t is equal to 1. Now, I notice that this does not work in this fraction. If I plug it in, I get 1 over 1 minus 1, I get 1 over 0, and we're not allowed to divide by 0. That was the only solution that we found algebraically, so that means that this has no solutions. So be careful. Sometimes you have many solutions, sometimes you have one solution, sometimes you have no solutions. You just have to check whatever you get algebraically that you're not dividing by 0 in this case. So good luck to you. If you have any questions, let me know. Otherwise, I'll see you in the next video.